this is our next laboratory in CPE 187, which is Embedded Systems Design. So in this lab, we're going to look over debugging and how we would do that inside of here. So I'm just going to look at this. This is our current code. It's not the code that came with this. The one that it did come with looked a little bit something like this. So let's switch out our fixes. The quick answer was what we had here, but we're going to go over why that's the answer and what we're supposed to do in a second, and why this code does not work, even though it looks very similar. So looking at this lab, we have our starter project. Going over the download and opening of these files is covered in the previous two videos in the playlist link below the like button. So we are going to read this. We have our purpose right here. We have our system requirements, which we've configured previously. And then we are going to just have a diagram that we can look at to describe what's happening here. So we have our switch 1 and we have our switch 2. We have our PF3, PF2, PF1, which are different ports. And the different ports have these different LEDs light up depending on what is pressed. So we have this procedure, and then we have part A, which is what's happening with our debug. We have the run the program. We can see what's happening with these inputs, why it's not working. Then we can generate a hypothesis concerning why the measured outputs do not match the desired outputs. And then we can look at all this. Then we can debug on the board, and we can compile and build that. These are our ports that we're going to be using. This is from our datasheet. So we have the ports here, GPIO port A, B, C, D, E, and F. 6 ports that we have right here. This is our system bus. We have our interface, and we have our launchpad development board with our switches being labeled here. So before we look into our code, we can answer these questions. We can look at the Tivia microcontroller high-level block diagram to see how much SRAM and flash ROM are available. So to answer this question about how much SRAM and flash ROM are available, we're going to look at our datasheet. I'll have hopefully a download to this in the description below the like button, but it's going to look something like this in our overview. So we can see this is our high-level block diagram. We have our SRAM right here. It's 32 KB, and then we have our flash, which is 256 KB. So very similar. We can just bring this over, and we can see that would be the answer for this. The next question is to look in the relevant chapter to see how many GPIO general purpose input-output pins are supported. So how many GPIO pins are supported? Well, if we look at our datasheet, again, the general purpose input-output pins offer flexibility for a variety of connections. The module is comprised of 6 physical blocks, each corresponding to an individual port. The module is FIRM compliant. It's compliant to the ARM Foundation for real-time microcontroller specification and supports 0 to 43 programmable input-output pins. So when this question asks us how many GPIO pins are supported, it's up to 43 GPIOs depending on our configuration. So we have 43 here, and we use the 6 blocks that I mentioned. And that's how we would answer those questions for this data sheet as well. So now let's look at our code for this and what's wrong. Well, if we run this, let's exit out of this debug because I was just playing around with it. We want to make sure that we are in our simulation right here. Click OK. Let's clear our board by cleaning the projects, building the target, and then we'll press debug here. It's going to enter an evaluation mode, and then we can click grade and see what we get right here. We're going to see that all of our tests are failing right now. It's telling us what the LEDs should be doing. Now that we know that these have failed, let's look through the code and see what's happening. We have a while loop right here. While our switch 1 is equal to our GPIO port F data R, and then we're assigning this, we're reading this right here. We're basically setting this initially to be this register, and then same with our switch 2, we're setting it to be this 8-bit register. Now we've gone over these previously, and that's in the previous video. These are basically just going to be your inputs. So you have unsigned long S1, S2, these are our inputs, and so we're just naming them like this, and we're assigning them here. And then we're doing some checks. If switch 1 and switch 2 are both pressed, it says, the LED should be blue right here. Otherwise, if only switch 1 is pressed, the LED should be red. Otherwise, if switch 2 is just pressed, the LED should be green. Otherwise, the LED will be off, right? Because nothing is pressed. Well, this is obviously not happening because the tests are failing. So after we've graded, we failed our grade, what can we notice that'll help us fix this? Well, what we can notice is that neither switch is pressed. However, our blue LED is lit. So what does this mean? Well, it means that it might be inverted. So let's look at this. If switch 1 and switch 2, we want our LED to be blue. However, right now, if neither switch is pressed, so this is this else statement, our LED is off. So what if we have this if statement be inverted? So we do not switch 1 and a not switch 2. Okay, let's try that. So what we're going to have to do now, is exit our debug. We're going to go to project, we're going to build our target, and we want to enter our debug again. From here, we can click grade. We can see both switches again are passed. We can see, more importantly, that both switches S1 and S2 are pressed. The LED is blue is passed. Now, when it's released, our switches are off. So that's what we have here. It's a good else statement. Now, what about the other ones? Let's run through and debug this. So it's saying when just switch 1 is pressed, our LED should be red. When switch 2 is pressed, it should be green. So let's pay attention and look at our grade when we go through this again. So let's run through this and pay attention to our switch 1 really quickly. So clicking grade, switch 1, we have our green LED lit. Switch 2, we have our red LED lit. It doesn't really show up here, which is a little bit weird. But if we toggle it really quickly right there, it shows that our red LED. Now, we want if just switch 2 to be green, just switch 1 to be red. So we can see that there's some issue here. They're inverted again. So let's switch our nots right here one more time. So we have our not switch 1, we have our not with our switch 2. We can save this, we can exit our debug. We want to build our project again. We can click debug, click OK, and let's see if we're able to go run this again. So we'll go to peripherals, TExaS port F, click grade, and try to get 100%. Doing our test, I failed it, and that's because I never got rid of this exclamation mark for switch 2 for green. So it was saying when both of them are pressed. That's a mistake right there, so I'm going to have to rerun this. Now regrading it with the correct code, this is what our code should look like in this while loop, and hopefully we'll be able to pass all of our tests here. So we've passed all the tests and we have gotten a grade of 100. Now let's exit this debug and we want to move on to our actual board part. So we'll click the debug here. We are going to click use Celeris CDI, click OK, and we're going to want to clean, I'll just clean it, just why not, and we'll build our target, we'll click debug, and then it should start our programming. What we're going to want to do is we want to load this onto our board. So we're going to click this run right here, and that'll load it onto our board. Now our code is on our board. Now there was no grading or anything that popped up here, but now we are looking at our board. So recall from our code on line 59 to 60, if we press both switches, our LED should be blue. So let's press both of them at the same time, switch 1 and switch 2 down here. We can see our LED is blue. We release them. Now if just switch 1 is pressed, our LED should be red. This is switch 1, you have a red LED. Now switch 2 should have a green LED, and we can see that if they're both off, it's blank. And so that is how this would work. If you're having any issues with your board, make sure that the USB is plugged into the top here. Make sure it's turned on to the setting right here. And for some reason, if it still doesn't work, there's a video, first video in the playlist, link below the like button, where I go over all of that in another way in the Windows command menu to actually help and get this to work. That's going to be it for this lab and how we would go about doing it.